Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this morning will be trigonometry, and this will now be lesson number 2. Okay, as per request on the viewers on my community post, they would like to hear something about trigonometry. Okay, let's proceed. The subject matter for this morning, it's a long video format lecture or discussion. The topic is trigonometry, lesson number 2. Oh, we are now on lesson number 2, guys. Sines of an angle, and I will be giving you a conversion problem with regards to the units of what they call this angle, that is degrees, radians, and something like a revolution. Okay, let's try to continue. The proper way on how to designate the sign of an angle in the study of trigonometry, this is a final thing, okay? As long as you are studying trigonometry, this should be the proper way on how to bring out the sign. Number 1. If the angle is measured clockwise, okay, the sign should be negative. Okay? If you try to measure an angle with respect to a reference line, and it goes with the rotation of the clock, it goes with the rotation of the clockwise, the sign should be negative. An example of this, it should be, if this is the reference line, have you seen? If this is the reference line, and I would like to, there is a line over here, line, right? It emanates from the origin, right? So if I will try to designate the location of this line with respect to this reference line, I could designate this one by having an angle measured clockwise. So with respect to this line here, if I will go like this, I could represent this one as negative angle theta. Okay, with respect to the reference line, okay, it goes with the direction of the clock, so we could designate this one as a negative angle. So for a clockwise rotation, okay, when we are designating angle, the sign should be negative. Okay, this is a negative angle. Okay, I will try to erase this one. It goes like this, right? With respect to the reference line, it goes with the direction of the clock, so it should be a negative angle theta. Okay? The reverse of this, actually, if we try again to designate the location of this one or the angle of this one by measuring it counterclockwise, we could designate it. So with reference to this reference line, if I will go counterclockwise meaning it is against the direction of the clock, right? Because clock is actually something like this. Counterclockwise will be the different one, okay? It go reverse. So if, with respect to this reference line, I could actually designate this one as, okay? It goes counterclockwise. I could place that one as angle alpha. So if I will try to designate the location of this one, I could place negative theta, or I could place this one as a positive alpha. Okay, since it is measured counterclockwise, the sign is positive. This should be plus alpha. Okay? Those are the only, what do you call this, signs of an angle under the study of trigonometry. If it is measured clockwise, it should be a negative angle with respect to a reference line. If it goes counterclockwise, it should be a positive angle. Okay? This is a general rule and it doesn't change, right? It doesn't change. Okay, since the last time around, I discussed the so-called units of angles. that is in terms of revolution, degrees, and radians. I will now try to bring out an example problem regarding this one. It's an easy one. So this is just a test on your knowledge on how to convert degrees or revolutions to degrees or degrees to radians. Oh, this is just a conversion problem. It's an easy one, but okay, it's one of the steps on how to study trigonometry. Okay, it's an easy one. Why are you giving us? Oh, it's an easy one. I just want to bring out an example problem on how to convert. Okay, let's try to bring out an example problem. Because there are some portions in trigonometry which are what we call this complicated. So on the easy ones, we take it easy, okay? Don't be bored on the easy problems, okay? It's a part of the study of concepts. Okay, let's try to bring out an example problem. A wheel is rotating at a rate of 56 RPM. RPM is revolutions per minute. Okay, express the angular speed and there are 3 units, okay? We express 56 revolutions per minute. The problem is asking what will be its value in revolutions per second and what will be the value in terms of degree per second and what will be the equivalent of 56 RPM in terms of radians per second. Because the last time around we studied the units of angles, right? That is in terms of revolution, degrees, and radians. So this is just a test on how we will convert a certain value to revolutions per second, degrees per second, and radians per second. Okay? Okay, let's try to bring out the figure. The figure will be something like this. This is a horizontal ground. I bring out a circular thing. We designate this one as the wheel. If we try to bring out a figure when we are solving problem, it doesn't hurt. Okay? And this one here is rotating at a rate of the designation for angular speed in the study of kinematics. This will now, kinematics is just the study of revolving parts for machines, right? So actually, trigonometry got a help on the so-called solution of problems under kinematics. And the designation for angular speed for rotating thing, okay, is actually omega. Omega. And the given problem, it is 56 revolutions per minute. So I am now just projecting this trigonometry to its application for the higher algebra, okay? Angular speed, that will be problems of kinematics. So for those of you who will be taking up mechanical engineering, okay, you are interested in what will be the speed of the rotating part of gears, right? So actually the angular speed used in kinematics is actually letter omega. Okay? I'm just telling you that angular speed is designated by Greek letter omega. And this is used for the higher up subjects later on when you are taking up mechanical engineering, because you are interested in the so-called study of the speed of the different rotating parts in a machine. So actually, trigonometry is one of the foundation of higher up subjects. Okay, omega, Greek letter omega. Okay, let's try to bring out this solution. This is an easy one. This is just a conversion problem. So, okay, it doesn't hurt. We'll try to bring it out. Omega is angular speed. This is used in kinematics. Kinematics is just a study of the so-called speed of revolving parts in a machine, right? And for the given problem, omega is actually 56 revolutions per minute. Okay? I will now try to bring out the proper way on how to convert under the study of engineering, right? Letter A, omega. The given problem, it is 56 revolutions per minute. We'll try to convert it to revolutions per second. So this is just an easy one. We'll just try to bring out the relation of minutes and seconds. The last time around, 1 minute is 60 seconds, right? 1 minute equal to 60 seconds. But in words, 1 minute is actually 60 seconds. Sorry for this one, it should be double prime. Okay? But when you are solving a conversion problem, don't use this one. Use the word thing, right? Because 1 minute is 60 seconds. It's better if you try to solve problem on the conversion, you will be using this. 1 minute is 60 seconds. So to bring out the conversion, okay, omega will be 56. RPM is revolutions per minute. Okay. The operation is multiplication. So this is algebra, okay? Times. Okay? 1 minute per 60 seconds. Right? That's a fact. 1 minute is 60 seconds. The operation is multiplication. So actually we can cancel this one. Right? But just in case this is plus, you cannot cancel it. That's why some creators on these short videos are complaining that they are canceling something, but there's a plus sign over here and they try to cancel it. That's why I emphasize here, the operation is multiplication, so actually we could cancel this one. Right? So after the cancellation of minute in minute, what comes out for the unit, just take a look what remains. It's revolutions per second, right? So to bring out the answer now in terms of revolutions per second, we divide 56 by 60. That's less than 1. It's 0.933 revolutions per second. Okay? This is the proper way how to convert, okay? So from now on, when you are having a formula and you're having a conversion, it should be like this. So you could visualize what remains on the unit after the cancellations. Okay, the operation here is multiplication. Letter B, we will be presenting the answer in terms of degrees per second. That's an easy one because on lesson number 1, we know the relation of degree in terms of revolution, right? So this is just an illustration on how to convert. So omega again, I will rewrite it 56 revolutions per minute. Right? 56 revolutions per minute. Okay, think of the conversion. The last time around, 1 revolution is 360 degrees, right? I give you that one. So I will multiply this. The operation is multiplication, 360 degrees per revolution. Okay? My motto here is to eliminate this revolution here. So I must have to bring out the relation of degree and revolution to eliminate this revolution. That is 360 degrees per revolution. That's a fact, right? Okay. But the problem is asking to be in seconds. So I will try to remove this minute here. And to remove this minute, the minute should be on the top portion, on the numerator, times 1 minute per 60 seconds. Okay? You cannot interchange it. You place 60 seconds here and minute over here. It will not cancel out. Because for the minute and minute to cancel out, they should be under denominator and they should be under the numerator. So the proper way will be times 1 minute per 60 seconds. Okay, then try to make some cancellations. If you write it legibly, you can actually visualize. This revolution here cancel with this, and this minute here cancel with this. What remains for the unit on the right hand side will be degree per second. Okay, so try to execute the division. Okay, this is 56 times 360 divided by 60, so 56. Okay, 360 is 6 times 60. Okay, all over 60, and the unit will be degree per second. Try to make some cancellations if you can. 60 and 60 cancels, so what remains will be 56 times 6 degree per second, or this is 336 degrees per second. Okay? This is the proper way how to convert. So when you go to higher up subjects, if you are simplifying a complicated equation, okay, and to get the proper unit of your answer, you should do it like this. Okay? Okay, this is the proper way on how to convert. Okay, letter C. Letter C, the problem is just asking for the angular speed in terms of radians per second. So again, omega, this is 56 revolutions per minute. I just rewrite it. Okay. I will try to remove this revolution here. So I will think of the relation of radians in terms of revolution. The last time around, one complete revolution is 2 pi radians, right? So this is multiplied. The operation is multiplication, okay? 2 pi radians per revolution. Because I want to eliminate this revolution here. You cannot interchange it. The revolution will be up. They will not cancel, okay? So the proper way will be times 2 pi radians. The unit of the revolution should be below on the denominator, so it will cancel with this. So times 2 pi radians per revolution, okay? And I would like to eliminate this minute here. So I will think of the relation of minute and seconds, that is times, the operation is multiplication, 1 minute per 60 seconds. Then try to make some cancellations. This revolution here, cancel with this. And this minute here, cancel with this. Okay? What remains for the unit on the right hand side will be radians per second. Okay, calculating the number parts, that is 56 times 2 pi. So this is 56 times 2 pi. This is all over 60. Right? All over 60. What comes out is 5.86 radians per second. That will be the answer. Okay guys, I think this is just more than good enough to illustrate the conversion of the different units of angles under the study of trigonometry. Okay? The next time around, we will continue with the study of trigonometry. Okay? So it's a very interesting one. Okay, good morning from Los Angeles. Professor David Generoso.